Good afternoon, everyone. This is Lingli from China Mobile, and it is my pleasure to share with you some of interesting intent-based network things that we have been doing with Huawei and other partners in ONAP. And to start with, why we're doing this intent-based networking or IBN in ONAP. Give you something about the background. We believe that intent is a must for autonomous networks, as the northbound interface of any autonomous domain as specified or expected as part of the autonomous network should be defined and provide service while intent-like interface. So intent interface is actually defining what an autonomous domain is expected to achieve, and with minimal human efforts involved in between. In other words, it actually expresses, or its presence, I should say, represents the key technologies of closed-loop management automation within that autonomous domain. And so due to its importance of this key technology, various standard development organizations has been started and doing study and specifications around this concept. And many of them invented variations in their specific contexts. And according to an E&I study that we have also been part of it, the industry reaches consensus on the concept, what is intent? And the consensus is that intent is used to describe what and not how. But unfortunately, that is pretty much all we have in common from these SDLs. Instead, we see variations for intent representation, for intent operation, and intent workflows, intent interfaces, and their specifications, and almost anything that was uncommon. So this could be a headache for any end-to-end orchestration system, such as ONAP. Well, we actually expect unified service intent representation for machine-to-machine automation across layers within autonomous networks. So that is the motivation behind what we have been setting to do this year. We would like to provide a reference implementation in ONAP for intent-based driven network to verify that SDO's proposals do actually work in practice and upstream to them to streamline this development and adoption. And that is also why that we are actually conducting these efforts in two threads. One is that we have been doing internal studies in different use cases to see how intent should be represented, its management function design, and their implementation. And on the other hand, we also would like to collaborate with the industry to see, how we can get the consensus that is needed. And now comes to something more in detail with the implementation in ONAP that we are doing. Before we delve into any implementation details, we believe that understanding some basic concepts is essential. So introduction to some of the basic concepts. According to TN Forum, definition for intent in autonomous networks, intent is the formal specification of all expectations, including requirements, goals, and constraints given to a technical system, which could be represented by an intent object that is conveying from the intent owner to the intent handler as a kind of like agreement between these two parties after their negotiation of what is to be achieved during this agreed time of period. And an intent instance is the carrier in the system or inside the intent handler with the formatted intent and keep a record of its fulfillment status. So in the target architecture of the autonomous network, as you can see to the right, from bottom to top, it actually includes 4 levels: network element management, network element, management or domain management, we should say it in some cases, service operation and business operation. And the intent management function, in our view, can be introduced into each of these layers. And the interface between the layers is therefore replaced by the intent-based interfaces, which are much, much more simplified and abstracted. And so, as you can also see from the figure, that there are 3 types of reference points between various functional modules. The first one is actually the intent management functions of intent owner, interacts with the intent management function of the intent handler. Those are the blue lines goes across different layers. And the second type is for format intent input interface on the left side, which is to taking into unstructured intent input, such as human input, as in natural language or something like that, and translate it into a formal structured intent representation as defined by the intent representation model. And the third type of interface is actually internal to this system and across all the layers, actually is for providing common capabilities that is needed for various layers of intent translation, and also knowledge generation and management for these different layers. And in order to support such architecture in ONAP, so we introduced some of the new functions into CON release, which includes intent interpreter function, which does the translation from the unstructured intent input into the formatted structured intent representation. And the intent management function, its own management function, which actually keep a record of all the intent handlers, what are they capable of doing, what types of intent do they support, and also it support the query from the intent owner when it actually goes to see what the system is capable of doing and what are the right intent to be issued for the system to achieve. Okay, from another perspective, the processing of intent in the system actually includes various different stages. Detection, which is the first stage. Actually, in this stage, the intent owner determines whether to issue any new intent or just making an update to an existing intent by detecting the satisfaction of requirements in the current system and see if there's any gaps in this expectation, and issues any new temporary intent objects if needed. And the second stage is investigation. Well, the intent owner and intent handler complete the revision of, if needed, the temporary intent object through investigation and negotiation to determine whether the issued temporary intent object is actually feasible by the system and does not do any harm to any other existing intents that was committed by the system. And creation. The corresponding formal intent object is created after the negotiation phase here, and then distributed during the distribution stage from the intent owner to the intent handler. And here, the intent object goes in its formal life cycle. Okay, and then if the intent handler accepts this intent object in a distribution stage, it then creates an intent instance and record it to the shared database and keep a record of its fulfillment stages there. Otherwise, the intent lifecycle ends immediately. And then the intent goes into the operation stage. Well, the intent handler operates its management domain according to the accepted intent to achieve the goals from the intent owner. And then in the assurance stage, the intent handler continuously ensures that the expectations is kept, fulfilled, and report its status until the intent is actually deleted from the intent owner. So this is the whole life cycle of the intent that needs to be taken care of. And in such a process, we identify several interfaces. Mandatory interfaces include intent creation, intent update, intent deletion, and also to support intent query from the intent owner proactively. And also another mandate, report interfaces should be implemented that could be used for intent handler to report its execution status and perhaps reasons for dissatisfaction if it is failed to meet the expectation. And also more optional interfaces could also be included in future versions, which include prop, explore whether the intent handler can implement a specific intent to be used in the detection phase and in the negotiate interface. Whether or not, the intent owner, intent handler could negotiate a potential revision to the original issued intent to make a deal on the fly to be used in the negotiation phase. And so here is actually the general intent model that we have been using. And this is actually a combination of different SDO proposals and also with necessary adaptation in ONAP implementation context. So for example, we took the elements of expectation target from TN Forum, and design of context, and expectation object fulfillment info from 3GPP. And also we coined in context condition, target condition, those type of concepts to address composite condition issues in implementation. And here's actually the components that fulfill these requirements. So some of the changes were made to the UUI component. The current architecture of UUI includes three major services: the GUI server and natural language processing server. So on top of that, a new microservice intent analysis server is introduced to provide intent decomposition, intent orchestration, expression, and analysis of general intent model, and all the general intent interfaces is supported by these microservice. And then I should show you the demo, but before going to the demo, I will do a very quick introduction of the case that is actually to be demonstrating. In this case, we assume that the service provider provides an intent-based cloud line service with corresponding assurance measures based on users' requirements. So the user is not only expecting a cloud line service to be set up, but also to be assured within its time, within its lifetime. So an enterprise user could issue an order with a bandwidth assurance requirement of 1 GB. And in order to meet this intent, the intent handler will configure with a bandwidth of 1 GB. At the same time, provides some high-level service quality assurance technology. For example, we can go with some of the dynamic policies. When the bandwidth utilization rate actually exceeds 80% of the quorum, the bandwidth will be expanded automatically by 60% to ensure that the user experience is satisfied. And at the same time, if the actual traffic returns to normal, and its utilization rate is lower than 30%, then the service bandwidth will be restored to 1 GB. So in implementation, as you can see here in the diagram on the right, actually the internal process includes several stages. First, the user's intent is input as the input information. And we will actually input this intent to the intent analysis server. And then the analysis server microservice decomposes the user's intent into two sub-intents. One is for the service delivery, and the other is for service assurance. Okay. So let me show you the demo.
Okay, we create intent about Cloudless LAN business from the UI and enter the intent name. Next, we add information about expectation. The expectation type of the first expectation is delivery, and the object type is the CCVPN, that is the Cloudless LAN. Next, we add the information of the expectation target. The first expectation target is source info. We describe the specific content through condition. Okay, here we get the source info. Input to the condition value. Okay, the second expectation target is the destination information. Here, we also use condition to describe the specific value of destination. Okay, we copy the destination and input. Okay, the third expectation target is bandwidth information. Here, we need to input the bandwidth, the maximum bandwidth. We also use condition value. The bandwidth we input is 1000 M. Next, we create a second expectation, Cloudless LAN assurance expectation. The expectation type is assurance. We change the expectation type to assurance. And the object type is also CCVPN. We add an expectation target. It is bandwidth assurance information. We add a specific content through condition. Here, we input the value. Value true means we will provide some high-level servers quality assurance technology. Through the input of the above information, we have created an intent with two expectations. Okay, and for the first expectation, delivery expectation, we can check whether the corresponding Cloudless LAN instance is created successfully through Postman. And from the result, we can see that we have successfully created the corresponding instance. Okay, we can also query the policy information to see whether a high-level service quality assurance has been created. It can be seen that the corresponding policy has been successfully created, and you can check the parameter. The orange bandwidth here is 1000 M, and the closed loop status is true. Okay, this policy corresponds to our second expectation, exclusive assurance expectation. Here we use graphs to simulate the increase in bandwidth utilization, so as to observe whether the high-level service quality assurance takes effect. Through this page, we can observe the bandwidth change of Cloudless LAN. The green line indicates that the maximum bandwidth we set is 1000 M, where the blue line indicates that the actual bandwidth is 300 M. As the time goes on, the actual bandwidth and the blue line the actual bandwidth used may exceed the maximum bandwidth due to the increase of usage. And at this time, the second expectation will work and provide a high-level service quality assurance. You can check the green line. The green line indicates the bandwidth as the maximum bandwidth will be continuously expanded to meet the needs of users. Finally, we provide enough bandwidth to ensure user experience. The user of bandwidth will change over time. You can check the blue line, and the actual bandwidth utilization rate of users decrease gradually. This blue line indicates the actual bandwidth utilization. And finally, the actual bandwidth utilization falls back to the orange line. You can pick the blue line. Okay, and at this time, the policy corresponding to our second expectation will detect that we no longer need to provide users with large bandwidth. You can check the green line, and now the actual bandwidth here is 300 M. So the green line indicates the maximum bandwidth. At last, the maximum bandwidth will be restored to 1000 M. Okay, it restored to the to 1000 M. Next, we will demonstrate the scenario of modifying the intent. Users may propose that they no longer need a high-level service quality assurance. So here we modify intent and delete cloudless line assurance expectation. We use postman to call. At this time, the instance of cloudless line still exists. We call the policy related to exclusive assurance. Okay, we can check the parameter about closed loop status. The closed loop status is false, indicating that we no longer provide high-level service quality assurance. Okay, we continue to observe the change of bandwidth through the monitor page, and it can be seen that when the actual bandwidth, the blue line, exceeds the maximum bandwidth, green line, the bandwidth is not expanded as before. This shows that our modification, our intent is successful. You can check green line. The green line is not expanded as before. Okay, last we will demonstrate the scenario of deleting the intent. We click the delete button on the UI to delete the intent. And in the intent list, the intent has been deleted. We call the information of the cloud list line created previously. Use postman to call the information. Okay, this instance no longer exists. This shows that our deletion of intent is successful.
And then talking about future plans. As you can see from the very brief demo, this is only a starting point with minimal functions for intent-based networking. So our future plan includes two perspectives. On the one side, we will continue to improve the development of IBN in the following ways: introduce more AI-related technologies, such as intent analysis, translation, decomposition, and other processes. And second, implement more intent interfaces, particularly those interfaces that was involved for intent negotiation and intent detection. And third, we plan to provide intent verification function, which would verify the effect and possible negative impact of the intent in advance before its formal assurance or distribution. On the other side, we continue to cooperate with open source projects and also via SDO collaboration, so that we can actually do this comparison between different proposals from SDOs, TN forums, RGBBs, ADSIs, and consider introducing new features into our next release. And at the same time, we could also upstream some of our concepts into their documentation. For example, the condition concept is recently adopted by TN Forum in their specification. And also we try to work here with open source projects, such as Nephew, to realize how to actually fulfill end-to-end intent through that intent hierarchy across different layers. And finally, we would like to see more use case application scenarios to be implemented and to demonstrate the flexibility and generosity of this intent-based networking capability provided by ONAP through its automation and closed-loop mechanisms. So, any questions that I can take? Sure, Ella. Yeah, I think we have one.
Okay, can you hear me in English? Okay, great. So thank you very much for the presentation. I have one question. You've mentioned in the beginning that this whole concept actually, its intention is to involve human in the process as to minimize it as much as possible, right? So I wanted to ask, can you shed some light on China Mobile approach related to that, because we do know that digital transformation, all service providers are talking about that, but they're still concerned about actually, let's call it closed loop automation, so without the ability of humans standing in the middle to affect the process. So my question is about China Mobile and its view, and what concrete steps China Mobile is taking towards this approach.
So this is not only about intent. It's about, whether or not we should actually keep human involvement in this automation and autonomy journey.
Yeah.
The answer is absolutely yes. I think it would be yes for any service operator if it wants to assure and take the responsibility of their services and infrastructure they're running. So human is expected to taking a key role, not less, in critical decision making for the daily operation, but not so necessary, but important decisions on whether or not the system is actually doing the work as we expected, and to fix it out if it does not. But much less human efforts might be involved in daily routine operation and maintenance tasks. That is for sure. So that we can save costs, we can transform our operational staff to more advanced AI technologies. They can be engineers, and they can be inventing new tools, automatic tools, intelligent tools to fulfill those manual works that they used to do from day to day.
So that already happening, that journey is already happening, speaking of China?
Yes, in China Mobile, we are actually, there was a talk that I gave earlier this morning talking about, China Mobile's practice in autonomous networks. We have been building a whole blueprint for the next generation network management system inside our group. And there we have built two common platforms to drive this innovation. One is called data sharing platform, and the other is the general technical platform, which does not say much from the name, but we're actually building the common CI/CD systems and also the AI platforms within that box. So that actually we have been Dr. Feng, who is actually the leader to our team of building that AI platform and enable all these various network AI applications. We have had our scale deployment in China Mobile's nationwide network in mainland China since last year. And by the end of last year, we're actually hosting over 100 different AI capabilities on that platform, which has been serving all of our 31 branches in China. So actually having tens of millions API calls every month. And it covers everything of the life cycle of management network that we can cope at the network management layer. And starting from this year, we're actually expanding this practice into more network domain layers, so the lower layer. And we are developing our specifications and required POC use cases with our partners in different network domains, including radio, core, telecom, cloud, IP, transport. Those are the 5 major areas that we are targeting at. And we also put this standards development and industry collaboration into our overall plan for this year and next year. We're actually doing this in an annual fashion in a closed loop. So that is currently basically what we have been doing.
Thank you very much.
Okay. So in case that we have very limited time and for this presentation, and I myself actually do not write the code for this demo. So in case you have any specific questions, you can actually ask my colleagues from China Mobile and also our partners from Huawei. And thank you very much for your attention and time. Thank you.